All right, folks. So, first off, what we're going to be learning about today is, let me share my screen with you guys. There, that it's circuit theory, hand calculations, and here's the worksheet. Notice it says to do 1 and 2 only. So you're only going to be doing these ones here, number 1, and then this number 2 and this number 2. That's still number 2 right here. Don't do 3 and later, okay? We'll learn about that later. So what are we learning about today? Is Ohm's law. And Ohm's law is quite simple, actually. That's Ohm's law right there. It's where V stands for voltage, and I stands for current, and R stands for resistance, and they're measured in different units. So voltage is easy. It's measured in something called, and it's called volts. I think everybody knows that, and it's abbreviated with V. Current is measured in a unit called amperes, but most people just call it amps, and it's abbreviated with an A. And R is resistance, and it's measured in a unit called ohms, just like Ohm's law's name, and it's abbreviated with a little like horseshoe omega symbol. It's a Greek symbol here called omega. Voltage is pressure, is called potential difference or pressure. The more voltage you have, the more pressure there is that forces electricity to flow. So if you have a circuit, and here's a battery, that's this is the negative side, by the way, and this is the positive side on a battery. So the longer side is the positive, and the shorter side is the negative. And if you have this battery and you go through a resistor, what flows is negative electrons. Negative electrons flow this way to the positive. Now I want to give you guys a heads up right now, and I'm going to tell you this a couple times, so please turn up your volume for this one. Notice I have a battery, and it's negative and it's positive, and I said electrons flow from the negative side. That's why this side's negative. It has lots of electrons, this negative side, and there's a lot of electrons there, and it flows through the wire and travels to the positive side where it's attracted to the positive side, and that's what causes current. However, what is really moving in the wires is electrons, and that is really the direction it moves. But in electronics world, if somebody says what direction is current, if they say what direction is current, you're going to say it goes that way. Okay? It goes from positive to negative. There is physically nothing that travels that way. This just boils back to a long time ago, a couple hundred years ago, when they first found out about electricity, and they noticed that the positive side, when they were using it, the positive side would go down, like it would start to, like, the battery die, and the positive would go down, and so like they're like, hey, notice that the positive depletes, like the positive starts to run out. So there must be positive energy flowing from the positive to the negative. So they said that current runs this way. So current runs this way. But later on, they learned about like electrons and subatomic particles, and what's really happening is negative electrons are leaving the negative side, and they come over and start canceling some of the positive side out. And so what's really moving is negative electrons. But in this class, and if you're an electrical engineer or an electrician, current always travels from positive to negative. Got it? Okay. Now, so pressure. How much pressure is here is considered voltage. Current is how fast the electrons are moving, how fast it's moving. It's actually in a unit called coulombs per second. That's how fast the electrons are moving in the wire. And 1 coulomb per second is considered an amp. And that's a lot of current, by the way. So this is literally your current, like as in like water flow. So if this was a water pipe right here, so if electricity was a water pipe, the pressure is your voltage. The current, how fast the water is flowing, so I'll say the flow, is your current. And resistance is like restriction, you know? Like a pinch, like a pinch in your water hose. So the more resistance there is, the harder pinch there is, which slows everything down, right? When you pinch your water hose, it slows water out. I guess you can pinch it so hard that no water comes out, I guess. But you could always just pinch it a little bit and it slows the water down. All right, so here's some practice problems. Ready, guys? So we're going to use this equation, V equals IR. That's the one we're going to use every time. Sometimes we will solve for I, and I equals V divided by R. And sometimes we'll solve for R, which is R is equal to, let's move the I underneath, so it's V divided by I. Okay, so these are the three equations we'll be using. It's all the same one, I just solved it for all three things. So if we know these two, and we're looking for this, we'll use this equation. If they give us these two, and they're asking for current, we'll use this equation. And if we know these two, and we're looking for resistance, we'll use these two. So let's just look at a resistor, one single resistor. The ohms on this one is, let's say that's 20 ohms. And how much current is traveling through? We'll say I is equal to 10 milliamps. Okay, I'm doing that on purpose, milliamps. We're going to have to convert that to amps in a minute here. And then, and so I want to know, what is the voltage? What is the voltage? Well, we're going to use this equation right here because it's saying what is the voltage, correct? So we're going to use that equation right here. So V is equal to I times R. That's all there is to it. If you know the amps and the resistance, just and the ohms, just multiply them and you're done. Now, we do know this one is 20 ohms. However, this one, the I, is given in 10 milliamps. And 10 milliamps, when you have millis and you need to go to amps, that's equal to 0.01 amps. How do I know that? Take the 10 and move the decimal place 3 times. 1, 2, 3. And so it's 0.010 amps, or 0.01 amps. So 0.01, that's the I, the R. So if they already gave you the amps, they didn't put a symbol here. If they didn't put a symbol right here, then you could have just put the number right here. So V is equal to this. And what is that number? All we have to do is pull out a calculator, and we do 0.01 times 20, and the answer is 0.2. 0.2 volts. So that's the answer, 0.2 volts. How do we know that? Well, because they're looking for volts, which means I'm going to use this equation because this is the one where volts is by itself, right? And then all I have to do is multiply the I and the R. So I multiply this number times this number. The only thing is they have to be in these units. So these units right here, like that. They have to be in those units. And this one right here was not. It was in milliamps, so I got to convert it, and that's why we learned that the other day. So if you don't know how to do that yet, practice. You can also just Google 10 milliamps, convert 10 milliamps to amps. Just type that into Google, and it'll convert it for you. So I can show you that right here if you want to see that right quick. So I can say convert 10 milliamps to amps. I just put A. So I just said convert 10 MA to A. And it says milliamperes 10 is equal to 0.01 amperes. So I was right. Okay, guys? So if ever you want to double check yourself or you're second guessing yourself, just go there, okay? That's why I put this number in here. That's how many amps there were. That's how many ohms there were. And I multiply them. That's it. Now the next one, let's solve for something else. There's a resistor. And for this one, we're going to use the second equation. So I'm going to have to make up two of these, a V and an R. So R is equal to 100 ohms. And the V is equal to 12 volts. And so how much current? I is equal to question mark. Well, for that one, we're going to use this equation because they give me these two, and they're asking for this one. So let's do that. I equals V divided by R. And notice that my volts is already in volts, so I can just put 12. It's not millivolts or megavolts or nothing weird. My resistance is not kilo ohms. Careful with that. If you see kilo ohms, you're going to have to times it by 1,000, okay? So it was not, so we just divided by 100. And once again, we're just going to take 12 divided by 100, and we get 0.12, 0.12 amps. And our answer is 0.12 amps. Or you could say 120 milliamps. Whatever one you want, both are correct, okay? Both of these are correct. That means the same thing. All I did is move the decimal place 3 times. Watch this, 0.12. 1, 2, 3. Put it here. And now I have this 120. And I call it milliamps. So you could do that if you want. It doesn't matter. So the last one I'm going to do here is I'm going to solve for R. R is equal to V divided by I. So R is equal to V divided by I. And so this one, since I'm going to use this equation, I need to say R is equal to question mark. I don't know what it is. And I'm going to have to make these two up for myself. So I'm going to say voltage is equal to 120 volts. That's how much voltage is in a plug socket in the wall. And then I have to make up the current. And let's go with, I'm going to go with a very low amount of current. Let's go with 1.2 amps of current. Notice I do not need to convert anything. These are in amps, these are in volts, so we're good. There's no kilos, no millis, no micros, no nanos. If there is, search on Google how to convert it. Once you have them in the correct unit, you just need to divide them. R is equal to V divided by I, and the V is 120 volts. The I is 1.2 amps, right? And so it's 120 divided by 1.2, and we can say 120 divided by 1.2 is 100. So 100 ohms is the resistance. Remember, resistance is measured in ohms, right? So we put 100 ohms. If you're not sure, here's my little chart. Resistance is measured in ohms. Current is measured in amps. Voltage is measured in V. And that's all three types of problems you'll have. The only difference that's going to make it harder is if they start adding, like, let me do one that's harder real quick for you guys. And let's pretend you guys don't know how to convert, all right? So let's do that. Let's pretend you don't know how to. So current is equal to, let's say 120 microamps. That's a very small amount of current traveling through that wire that way. The voltage is equal to, let's say, 100 volts. So the resistance, what is it? Well, by the way, this is going to be a very big resistance. You know why? Because we have plenty of voltage, but man, we only have a very little bit of current. Okay? Very little bit of current. It's 120 microamps. Okay? So, which equation are we going to use? Well, which one has the R by itself? It's this one right here, right? R equals V divided by I. That's the only one with the R by itself. So all we got to do is take V and divide it by I. I have the 100 volts right here. We're good. But I can't put 120 microamps. Do not put 120 here. That will not work. Why is my son calling me Steven? Yeah, what? Yes. So let's go here and convert. So I'm going to prove to you that you can go to Google and just literally, let me prove to you and just go to Google. Here's Google. You can just type in 120 UA microamps to A. See that? Because I just need to know how many amps that is. They gave me microamps, so I need to put just amps. So I'm going to put that and push enter. And 120 microamps is, oh, astronomical units. Oh no, that's not good. That's not what I was looking for. Microamps. It's not here. Okay, let's type in 120 amps. Let's see what happens when I do that. Let's do it. 120 microamps to amps. Let's see that one. Microamps to amps. There we go. Boy, that was a bit of a pain. So 120 microamps is 0.000. That's 3 zeros with a 1-2 amps or amperes, right? Remember, that's the other name you can call it. So there was 3 zeros there. So let's write it. Zero. Wait. My pen's not working. What did my son do? Oh, 0.00012 amps. So now we're in amps right here, see? So we can actually do the math now. So let's do 100, and let me move this real quick, divided by 0.00012 amps. So 833,000. 833,333, and do not put the point whatever. You don't need to put the decimal numbers. So don't put that stuff. Just this number right here is good enough for me right here, just the whole numbers. And so you're pretty much done. It's that many ohms. Now, you could probably just write and round it and just say 833 kilo ohms. Because remember, this is the thousands spot right here. This is the thousands. So 833,000 ohms. Kilo means 1,000. So 833,000 ohms. Either one of these answers is good. Doesn't matter. 833,333 ohms, or if you just round it to that, that's good as well. So both are good. Now, my last one. My last part. By the way, everything I did right now is just for number one. Okay? That's how you do number one. Number two is series and parallel. Series circuit, resistance. This one's going to be easy. This is easy, boys and girls. Here's the negative side of the battery right here. Here's the positive side of the battery. And here's a resistor. Here's a resistor. And here's a resistor. And I'm going to put this one as 300 ohms. This one is 1.2 kilo ohms. I'm doing that on purpose, all right? I'm purposely putting that kilo there so it throws you off for a second so you know that you have to pay attention to that. And then we'll put this one at, 500 ohms, okay? What is the total resistance? Everybody look at this. This is number two, total resistance. How do we solve for this? We just look at this because this is a series circuit. How do you know it's a series circuit? All the electricity travels here. Then it goes into this one. It comes out and has to go in this one to come back. So they all have to go through each other. And so when this happens, you literally just add it up. The equation is total resistance is equal to resistance 1 plus resistance 2 plus resistance 3. That's it. And so on and so forth if you have more, by the way. Yes. Okay, I'll be right there, okay? And then, so the equation is 300 ohms plus 1.2 thousand ohms. So that's 1,200 ohms. You got to write it like this, okay? Don't put, oh, that's 1.2 ohms. Do not write that's 1.2 ohms. It is not. It's 1.2 thousand ohms. So 1,200. Just move that decimal place 3 times. 1, 2, 3. So you're going to add 2 zeros there. Plus the last one of 500. So that's going to be, what's that? 300 plus 500 is 800 plus the 1,200. That's equal to 2,000 ohms of total resistance. That's the total resistance for this whole circuit. You add it together, it's really simple. You just add them up. Here's the harder one. New. Yes. Here's the, let's go to, okay, here we go. So here's the harder one. Resistance, resistance total for parallel circuits. And they look more like this. And we'll get more into detail about this later. But they look like this. You'll have electricity traveling through here, right? Kind of coming out of the positive side, remember? Because this is the positive side. And it'll come through and go to a resistor. Let's say that's 200 ohms. And then it'll go through this other one. And let's say that's 300 ohms. And then just to make things spin it up a little bit, 1.2 kilo ohms. Let's do that one again. Kilo ohms. This is a parallel circuit. Notice not all the electricity always travels through all of them. Some of it goes through here and then comes back. Some of it will go here and then come back this way. And some of it goes all the way down into this one and then meets back, and then they all come back and meet on this side. This is a parallel circuit. The equation is a little funky, everybody. 1 over the total resistance is equal to 1 over the first resistor plus 1 over the second resistor plus 1 over the third resistor, and so on and so forth, depending on how many you have. Here I only have 3. So the math is a little crazy, but not too much. Just watch this. Just follow along with these steps. Take 1 divided by RT, that's the total resistance we're going to be looking for, and put 1 over 200, that's the first one, plus 1 over, the second one is 300, plus 1 over, don't write 1.2, that's 1.2 thousand ohms, okay? So that's 1,200, and that's it. We only have these 3 resistors. Okay, now let's put the calculator. Watch this. Start dividing these right away. You don't want to try to find the common denominator. Don't do that. You're just going to spend all day doing that. 1 divided by 200 is 0.005. So 0.005. So that's this one right here. And let's do the next one. 1 divided by 300. 1 divided by 300 is 0.00333. 0.0033 repeating, right? Plus 1 divided by 1,200. 1 divided by 1,200 is equal to, that's a big number. It's 8.33 times 10 to the negative fourth. Oops. 8.33 times 10 to the negative 4. So what is that? That's move the decimal place 4 times. 1, 2, 3, 4. So there's 3 zeros here. So 0.000833. So 0.000833. There's our 3 numbers is equal to this. Let me scroll up a little bit. And let's add all 3 of these together. Where's my calculator? Did I just make my calculator go away? I have to rewrite that now. All right. So here we go. It's 0.00. Was there 2 zeros or 3? I think it was 3. It was 3 zeros. 0.833 plus 0. I'm working this way, then this one, then this one. I'm kind of working that way. 2 zeros, 2 threes. There we go. So plus 2 zeros, 2 threes. There we go. Plus, and let's do the last one, 0.005. Like that. Enter. And our answer is 0.009133. 0.00. Now we're not done yet. If you take 1 divided by RT, you'll get this number. So I don't want to know what 1 divided by RT is. I just want to know what RT is. So we're going to reciprocate this side, which means I have to reciprocate this side. Okay, and then my answer is, that wasn't cool. My answer is, I'm going to show you the easy way to reciprocate. You see how that was my answer and I have to reciprocate that? Just push the 1 divided by x button right here. You could take 1 divided by this, go ahead. It's extra work. Type in 1 divided by 0.009133. You could do that, but I could just push this and it reciprocates it. 109.5, I guess, if I round it. So I'm just going to put 109 ohms. That is the total resistance of this circuit. One way to know you did it right, if you want to know if you did it right, is look at the number you got for the total, if it's in parallel, and it should be lower than the smallest one here in parallel. So what's the smallest one? This is 1,200, that's 300. This one's 200. This is the smallest one. This answer should be smaller than that. Because as you put resistors in parallel, they actually drop the resistance. So definitely we got the right answer here. And that's pretty much it.